Hi, this is the first of 3 videos for the topic of statistics for the International Baccalaureate course, Analysis and Approaches. This first video we're going to look at data collection. Here's the lesson outline. We're going to look at statistical investigations, population census and sample, error, types of variables, discrete data and continuous data. So a statistical investigation involves collecting information, organising, displaying and analysing the information, and then drawing conclusions. And here's the process. We start by stating a problem, choosing a sample, and then deciding on what variables to measure. Now, if the entire population is surveyed, this is called a census, but it's nearly always impossible to collect information from the entire population. So instead, a random, unbiased sample is used. There are different types of samples. There's simple random sampling. That's where you might use a random number generator, or you put names into a hat and draw them out randomly. There's systematic sampling. This is where you use a system to select your participants. You might choose every 10th person in a list. Convenience sampling isn't necessarily unbiased, but it might involve you standing at the front of the school or a shopping centre and surveying the first 10 people who arrive. Stratified sampling is where we want equal representation of different stakeholders, like equal representation of males and females. Quota sampling is very similar, except you would use a convenience method to choose the participants. Here's an example of stratified sampling. Henry is conducting a survey regarding the building of a new exercise facility at his school. He wants to have equal representation from all stakeholders, parents, teachers and students. How many parents should he survey? If he wants a sample of 50 and there are 795 parents, 420 students and 32 teachers. Now this is just a matter of doing some fractions. We're going to get the total first of all. So we're going to do 795 plus 420 plus 32. And so I've got 1,247 people all up. So let's just write that number down. 1,247. We want a proportion, or the proportion of parents. So that's 795 over 1,247. Now I want 50, or he wants 50 all up. So I'm going to take that fraction of 50. Now it's not going to work out particularly nicely. Let's just do it on the calculator. 1247 times by 50. I'm going to get 31.8. And you can decide whether you want to round that up to 32 people or down to 31. But that's how you do it, how you work out a stratified sample and the proportions required. Now I mentioned before that a sample needs to be unbiased. This means that each member of the population has an equal chance of being selected to be in the sample. So what's wrong with this sampling method? Catherine chooses the first 60 people on the alphabetic list of parents at the soccer club. The easy way to figure out the bias here is to think about who can't be included. So anybody who's after the 60th person on the alphabetic list isn't able to be part of the sample, therefore it is biased. Let's move on to error. There are 4 main categories of error. The first one is sampling error, and this is where the sample is not indicative of the population. It's usually not the fault of the statistician, it just happens that the sample doesn't have the same opinions as the whole population. Coverage error is very similar. The sample will not be indicative of the population, but usually it's because the sample's not big enough. There's not enough coverage. Measurement error is in the taking of the statistics, and non-response error is where the participants choose not to respond. Now once we've chosen our sample, we have to decide which variable or variables we're going to collect. And a variable is any characteristic, number or quantity that can be measured or counted. It's also called a data item. There are 2 types of variables. There are numerical variables, just means it has a numerical value, and there's categorical variables. It has a quality or characteristic which can be divided into categories. There are 2 types of numerical variables. There's discrete data, and discrete data takes exact values and is often the result of counting. 2 examples include populations and test results. Think about it, populations are whole numbers, we can't have half a person, and test results, also whole numbers, although maybe we could get 7.5 out of 10. The point is, they are discrete, exact values. We couldn't get 7.963 out of 10. Continuous data takes a range of values, and it's often the result of measuring, like rainfall, height, and temperature. Now, in these cases, they're not whole numbers, they're decimals. Could be 23.241 millimeters. Same with height, same with temperature. Now, after we collect the data, we need to organize it, and we do that in a frequency distribution table. So here's our discrete data, 0, 1, 2, 3, 4. We have a tally, which tells us how many of each there are, and frequency means how many or how often. So this tells us there are 5 zeros, 8 ones, 3 twos, 2 threes, and 2 fours. And this means the sum of the frequency column. So altogether there are 20 data points. Relative frequency is like probability. It tells us the proportion of each. And to get this 25%, we just do 5 out of the total. It's 5 over 20 times 100 to make a percent. So 25% of the data is zeros, 40% are ones, etc. And after we organize our data, we have to display it. And discrete data is displayed using a column graph. And we leave gaps between the columns to indicate the distinct nature of the data. Here's our data set from before. You can see how we've got 2 threes and 2 fours, but we have no 3.5 or 3.7 because it's discrete data. So that's why we leave the gap. The mode is the tallest column, which is here. So in this case, the mode is 1. By graphing our data, we can determine if the distribution is symmetrical or if it's skewed. And there's 2 types of skew. There's a negative skew and a positive skew. Now, this negative and positive comes from when we subtract the median from the mean. So that would be a negative in this case and a positive in this case, but it's quite tricky to remember it. It is back the front to what you'd think, because in this case, the big hump is sitting more over the positive numbers, and in this case, it's sitting over the negative numbers. So if you need to remember it that it's back the front, then that's probably as good a way to remember it as anything. The shape of the distribution will also show us whether there are any outliers. An outlier is a data point that's far away from the rest of the group. Now here's an important point. Outliers should be included in the data unless they are the result of human error. Now, it's possible with discrete data that we might have too broad a range to be able to manage it. So when there are many different data values with low frequencies, it's best to group the data into classes. A perfect example is exam scores. If you think about it, suppose they're out of 100%, we could get somebody getting 0% and another person getting 100%. That's just not manageable. There are different ways to divide data into classes, but as a general rule, we try and divide into between 6 and 12 groups. Here's an example. Following are the number of cars passing an intersection over 40 days. And you can see a lot of different numbers there with low frequency, so we need to group them. What we need is the lowest, which is 57, and the highest, which is 92. So let's find the range. 92 take away 57 is 35. Now there are different ways to do this. Remember, we want between 6 and 12 groups. Now I can see 7 5s are 35. So if we start from 55 to 60 and then do 60 to 65 all the way up to 90 to 95, we've got 8 groups of width 5, and that would be pretty good. So here's our frequency distribution table. Here are our groups, our tally, and our frequency, and here's our column graph. And you can still see the gaps between the columns because it's discrete data. This goes from 55 through to 59. There's no 59.5, for instance. The modal class is the tallest column, so that would be this one. And finally, continuous data. Data that's continuous doesn't have an exact value. It has been approximated. So we should group the data into classes of equal width, like here. So suppose this is the length of fish that were caught. We have a group between 1 and 2 centimeters, another group between 2 and 3, and then between 3 and 4, all the way up to between 8 and 9. When we graph the data, we use a frequency histogram, which is very similar to a column graph, except we don't have any gaps. And this shows the continuous nature of the data because we move seamlessly from one into the next, showing the whole range of values. Okay, that's the end of this lesson. In our next lesson, we're going to look at descriptive statistics.